Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. In this video, we'll solve a polynomial inequality. The given inequality is x cubed plus 5x squared plus 2x minus 8 less than or equal to 0. This is a cubic inequality. The given polynomial expression is a cubic expression. The first step is to factor this cubic expression. We cannot use grouping method to factor this cubic expression, so we have to use rational roots theorem to factor this expression. The leading coefficient for this cubic polynomial is 1 because the coefficient of the x cubed term is 1. So the possible factors for this cubic polynomial are the factors of the number term -8. The possible factors of -8 are plus minus 1, plus minus 2, plus minus 4, and plus minus 8. Next, we should sub in these values one by one in this cubic polynomial and find the value for which the value of this cubic polynomial becomes equal to 0. Let's assume the cubic polynomial can be represented by function f at x. Now we can sub in the values one by one. Let's start with x equals 1. One cube is equal to 1. 5 times 1 square is equal to 5. 2 times 1 is 2. F at 1 is equal to 0. That means at x equals 1, the value of the cubic polynomial becomes equal to 0. So a factor for this cubic polynomial is x minus 1. Next, we have to find the other factors for this given cubic polynomial. We should use polynomial long division or synthetic division. In this problem, I'll use synthetic division. We start by writing the coefficients in the given cubic polynomial. 1, 5, 2, -8. We write the x value from the first factor outside on the left side. Now we can start the synthetic division. The first step is to bring the first coefficient down. Now we do 1 times 1, which is equal to 1. We put 1 under the 5. 5 plus 1 is 6. Next we do 1 times 6, which is equal to 6. We write the answer under the 2. 2 plus 6 is equal to 8. 1 times 8 is equal to 8. -8 plus 8 is equal to 0. Since the last number is equal to 0, that proves that x minus 1 is a factor of the given cubic polynomial. The degree of the cubic polynomial is 3. The degree of the factor we found x minus 1 is 1. So the degree of the quotient of this polynomial division should be 3 minus 1, which is equal to 2. So the quotient of this polynomial division is 1x squared plus 6x plus 8. So we can write the given cubic polynomial as x minus 1, the first factor we found, times the quotient of the polynomial division. This is the given inequality in partially factored form. Now we can factor it further. We can use simple trinomial factoring to factor x squared plus 6x plus 8. We have to find two numbers whose sum is 6. and product is 8. The numbers are 4 and 2. So the fully factored form of the given inequality is now we can find the x-intercepts for this cubic polynomial by setting each factor equal to 0 and solving for x. I get x equals 1, I get x equals -2, I get x equals -4. So the x-intercepts are 1, -2 and -4. Now we can use the number line method to find the solutions for the given inequality. We should plot the x-intercepts on this number line. These x-intercepts divide the number line into 4 intervals. We have to test the inequality in these 4 intervals. We have to use a test value in each interval. To the left side of -4, we can use the test value -5. Between -4 and -2, we can use the test value -3. Between -2 and 1, we can use the test value 0. And to the right side of 1, we can use the test value 2. At x equals -4, -2 and 1, the inequality is satisfied because these are the x-intercepts for the cubic polynomial. The value of the cubic polynomial is equal to 0 at these x values. Therefore, these three x values, -4, -2 and 1, should be part of the solution for this inequality because we have to find the x values for which the cubic polynomial is less than or equal to 0. Now we can use the test values. Let's start with the test value x equals -5. We should sub in x as -5 in the given inequality. I get -18. -18 is less than 0. Therefore, the inequality is true in the interval on the left side of -4. Next, we can use the test value -3. We should sub in x as -3 in the given inequality. I get 4, which is greater than 0. Therefore, the inequality is not satisfied in the interval from -4 to -2. Next, we can use the test value 0. I get -8, which is less than 0. Therefore, the inequality is satisfied in the interval from -2 to +1. Next, we can use the test value 2. I get 24, which is greater than 0. Therefore, the inequality is not satisfied in the interval to the right side of 1. Now we can write the solution for this inequality in inequality notation. We can write this solution in interval notation as this should be the final answer for this inequality. So these are the steps you have to keep in mind to solve a problem like this one. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.